Hi there, and welcome to this lesson on graphing linear inequalities in two variables. Please like this video if you find it helpful, subscribe for more math help, drop a comment question below, and check out some of the other playlists on the channel. We have some really specific playlists that might help you in your math classes. And without further ado, let's go on into the new content. Full disclosure, there's been a lot of stuff going on in my apartment, so you might hear some background noises, kind of recording this in an unconventional setting, and I apologize in advance if you hear that. So never lose sight of the key ideas. When I'm teaching in my own classes, I'm always talking about certain key foundational ideas that undergird so much of what we do in math. And if you get these key ideas, it's going to allow you to springboard into higher levels of math without any drama. So one of those key ideas is that we always shade the points that make the statement true. In other words, the graph is the picture of the solutions. So we want to remember two key things there, that the solution or solutions make the statement true, and that works for equations as well as inequalities. And the graph pictures those solutions. In other words, it gives us a visual of where the solutions are. And that always works for all kinds of equations and inequalities. So you never ever want to lose sight of what is the solution and then how are the solutions related to this visual graph that we create. So we're going to build on what we already know here because math is foundational. It builds up from concepts that you already know. So on the left, we have the equation 2x minus y equals -3, which is an equation that you should be able to graph by the time you reach this point in Algebra 1. And we're going to take a look at that just by building the table. We won't stay there for the entire lesson, but suppose x is equal to 0. Okay, so x is equal to 0. We would go ahead and plug in a 0 for the x. 2 times 0 is 0, leaving me with -y equals -3. And then we could either multiply or divide both sides by -1. Negative divided by negative would give me a positive, and so we get y is equal to 3. And what that means is that the point 0, 3 is going to be on the graph of that line. And we could pick the point 1, and we just kind of repeat that process with the 1. So 2 times 1 is 2. This time we'll have to subtract 2 from both sides. So 2 minus 2 is 0, again leaving me with a -y. -3 minus 2, or -3 plus -2, okay, whichever way is going to help you there. And then we need that to be a positive y, so we do the same thing. And we get the point 1, 5. And then what we know from our study of lines is that every other point on that line would also work. Now, I'm freehanding that line, but we could, in theory, pick an infinite number of other points. We could get all the dots and make sure that they all worked. And in all the dots in between the dots, okay, all of those work. And what we don't want to do is draw in an infinite number of dots. And so what we do is we plot as many of those dots as we need to know where the line is. And then we just connect them with this solid line that indicates, hey, like these points and all the points in between them. Now, looking at the expression or statement on the right, we've got 2x minus y is greater than or equal to -3. So we should notice some things that are similar. First of all, we see the equal to. So we know that the line is part of the solution. And what I'm referring to is right here. We know that that means or equal to. So 2x minus 1 is greater than -3 or equal. Equal would also work. So that line that we just graphed is a part of the solution. Okay, so we're going to start there. Okay, we've already got a bunch of the solutions already on there. But we also need to figure out, what are we supposed to do with the greater than? What are we supposed to do with that? So we need to include something for the greater than. So how can we know where this is? How do we know where greater than is? Well, there are two ways you can do this. One is with test points, and the other is using slope-intercept form of the line. Let's take a look at the test points. So we're going to start with this same line. So I'm going to go ahead and plot those points again. So we had the point 0, 3, and we had the point 1, 5. And we know that those points, as well as all of the points on that line, are solutions. And what we're going to do is just check some points, and we're going to look for a pattern to see if we can figure out where are the points that will satisfy the greater than. Now, this is going to be a little bit tedious, at least at first, but we're going to get to a quicker way to do it. For right now, though, we mostly need to establish the pattern. So we're working with the inequality 2x minus y is greater than or equal to -3. And each of these ordered pairs is an xy pair, so we're going to plug them in and just see if they work. So we have 2 times 0 minus 4. And we want to see, is that greater than or equal to -3? Well, 2 times 0 is 0, leaving us with -4 is greater than or equal to -3. Well, -4 is not greater than or equal to -3. Now, if you're like, well, wait a minute, but 4 is greater than 3. Remember that we're on the number line here. Okay, here's -3, here's -4, and you can see that it is to the left. And so that is actually not greater than. And so I'm just going to come over here and mark that and just say the 0.04, like that did not work. I'm going to mark that with like just an X. Okay, that did not work. Now, this does get a little bit tedious, but again, we're looking for a pattern here. So let's go ahead and look at the next one. So this is going to be 0, 0. So 2 times 0 minus 0 is greater than or equal to -3. 2 times 0 is 0. 0 minus 0 is 0. 0 is greater than or equal to -3. Well, if I come up here to my number line, yes. Okay, that actually does work. And so here I'm just going to put like a little check mark at the 0, 0. It's very informal. Moving on to the next one. Oh, I skipped over -1, 6. So let's go ahead and do that one. So 2x minus y is greater than or equal to -3. So this will be 2 times -1 minus 6. So this is -2 minus 6. And if you were doing this not in a lesson, as soon as you see like whether it's true or false, you can just kind of move on. Remember that this is -2 plus -6. So this is -8 is greater than or equal to -3. And that is false. So we're just going to say no, it's false. This one was true. This one is false. And so -1, 6 also did not work. Moving on to the next one. We have -3, 0. So 2 times -3 minus 0 is greater than or equal to -3. This is -6 minus 0. And -6 minus 0 is -6. And that is not greater than -3. So going to find -3, 1, -2 right here. Okay, also not working. All right, a couple more to go. So we have 2x minus y. This time we're going to do the point 1, 2. So x is 1, y is 2. 2 times 1 is 2, and 2 minus 2 is 0. And so 0 is greater than or equal to -3. Yep, we got that in there. So this was the point 1, 2. So the point 1, 2 is right here. Okay, thereabouts. And last but not least, we have 2x minus y is greater than or equal to -3. And so plugging that in, we've got 2 times -1. Now be careful here. This is going to be minus -2. You've got a minus in the inequality and then a minus on the number. 2 times -1 is -2. Negative of a negative or minus a negative would be adding. Oh, adding a 2. So plus 2 is greater than or equal to, and negative 2 plus 2 is 0. And we end up with that again. 0 is greater than or equal to negative 3, which we know is true. And so -1, -2 works, which is kind of down here. Now, what I want you to do, and you can pause the video for a moment and just kind of look, do you see a pattern between where the X's are and where the check marks are? Okay, just think about it. And what hopefully you thought about, okay, is that all the points on one side of the line are solutions and should be shaded. So we've got like these X's, these points that did not work, and they were all on one side of the line together. And then we had these 3 points that did work, and they're also on one side of the line together. Now we could keep doing this. I could, like if I were doing this in a class, we could assign 6 points to all the students in the class, and you all check them. And what would happen, okay, you kind of have to trust me on this. What would happen is we would just end up with X's all over one side and check marks all over the other side. So if you don't believe me, okay, so if you're like, I don't trust this dodgy person that I found on the internet, pick a point that you know for sure. Okay, try to avoid stuff super close to the line if the line is a little wobbly. Like I'm not totally sure, but like go ahead and pick, this is the point 6.2. Go ahead and pick the point 6.2. 6.2 is going to be a check mark. Go and find something that's on the other side. We've got the point -6.0, okay? Go and plug -6.0 in. It'll be an X. Like there's a way that I picked those points so that I knew 3 of them were going to show up on one side and 3 were going to show up on the other side. And so what we find here is that there's one side of the line where everything is false and the other side of the line where everything is true. So when we go to graph it, we graph and we shade all of the solutions. Well, if all of the solutions are on one side, what we do is we shade that side, okay? And that shading indicates this side, like this line, and then all of the points on that side. Now, this is actually good news because what it means is that you do not have to test all kinds of points. You actually only need to test one point. So let's take a look at this. We've got y is greater than or equal to 3x plus 4. So I'm going to graph this the quick way that we know. We know that the y-intercept is going to be 4. Okay, so put my dot right there. Maybe put the dot there. And we know that the slope is 3. And so that could be written as 3 over 1. So this is rise over run. So I count up 1, 2, 3, and over 1. And there's my line. Now, the good news here is that I only need to test one point because either like I'm going to test one on the true side that works and then I know I'll shade that side, or I'll test it and it will be false, which means I have to shade the other side. Like the other side must be the true side. So now when it comes to picking your point, I would say if the point 0, 0 is available for you to pick, go and pick it, okay? Like pick the point 0, 0. 0s are easy to work with. If the line goes through the point 0, 0, then you can't pick 0, 0, and I would pick something like 0, 1, okay? Because if it goes through 0, 0, it won't also go through 0, 1. That's maybe a discussion for a future lesson. So I'm going to go ahead and pick 0, 0 here. And I get 0 is greater than 3 times 0 is 0, and 0 plus 4 is 4. So I have 0 is greater than 4, which is false. So that tells me that's the false side of the line. Like all the points on that side are going to be false, which means the other side of the line must be the true side of the line, and we shade all the things that are true. Okay, so there's my shading. And that's how we graph linear inequalities using the test point. Okay, so I know that was a little bit lengthy, but I think it's really important that you see how that works, because otherwise you will just end up trying to memorize stuff without knowing why we're only shading one side of the line. Okay, so what about the other method? If the inequality is in slope-intercept form, or we put it in slope-intercept form, we can focus on the y values to figure out which side to shade. So if the y values are less than the line, okay, I left out a word there, have to be less than the line, you shade below the line, because less than on your y-axis, okay, so if we look at, here's my y-axis right here, these are my greater numbers going up, because I'm going up like 8, 9, 10, 11, 12, and my less numbers are heading in the other direction, going down. So -2, -4, like those are your less numbers. So if the y values have to be less than the line, you're going to shade below the line, because that is where you will find y values less than the line. If the y values have to be greater than the line, shade above the line. And just take care when the line is very steep, as it's easier to think left, right than below, above, and I'll show you what that means. So here we have our line, y is less than or equal to -2x minus 1. So I go ahead and we know the y-intercept is the point 0, -1. So I go ahead and put my y-intercept there. My slope is -2, or -2 over 1. So I'm going to go down 2 and right 1. 1, 2, there it is. Okay, I go and put my line in. And now I'm going to focus on this less than, okay? So the y values have to be less than whatever the line is. So if I look over here, I had written this earlier, like above, as you go up on the y-axis, that's going to be your greater than numbers. If you go lower, this is my less than side. So this is the side that I'm going to shade. I'm going to shade the side that has the less than, and that's all it is. So honestly, if you have it in slope-intercept form, you don't need to show any work for this at all. You can graph it using the y-intercept and the slope, and then use the less than, greater than to decide which side that you want to shade. So good news if you don't like to show a lot of work. Now, what if the line is not included? All the ones that we've been looking at have been like less than or equal to, or greater than or equal to. What if you just have a less than or a greater than, and you don't want the line itself to be included? Well, this is similar to when we are graphing on a number line and we don't want to include the endpoint. So if we had something like x is less than 3, okay, we know all the numbers that are less than 3, but we want to make sure that we mark the boundary of the 3, but that the 3 itself is not included. Okay, so we need a way to show that the line is a boundary, but not include the line itself. And when we are doing this with the number line, what we do is an open circle. So we put the circle there, but we don't shade it, because shading means that it is a solution, and we know that 3 is not a solution, so we would not shade it. So what do we do if it's a line? Well, we do it with a dashed or a dotted line. So this is analogous to the open circle. And I typically will use the word dashed, but I have had students come to my classroom that say dotted from whoever their teacher was. So what we do there is we create this line that essentially marks a boundary. Okay, so you can clearly see where the line is, just like you have the circle, okay, marking the boundary, but it is technically an unshaded line. So we are not shading it. We are leaving it open, saying, here's the boundary. We can go up to the line, but the line itself is not included in our solution set. So that would look something like this. And I'll do this one without showing any like scratch work or anything, just so you can see how simple these problems can be. So in this one, we have y is greater than 3x plus 4. So I know my y-intercept is 4. So there it is. The slope is 3 over 1. So starting at the y-intercept, I'm going to count up 1, 2, 3, and right 1. That's going to give me my 2 points. Now, this time, the line itself is not included. So I'm going to connect them, but I'm going to connect it with a dashed line. All right. And that shows that like this is my boundary, but the boundary itself is not included. And now I'm going to use my y is greater than, and I'm going to remember that on the y-axis, The greater numbers are above. Okay, they're going to be up here. So this is the side that I'm going to shade, is the above. And there you go. Okay. And that's really all there is to it. That is like how you can do this. You don't really need to show any work. Now, a couple of things that I caution my students about that you want to be careful of. One is make sure that your teacher is able to see a couple key things. Okay. This is what I tell my students. Make sure that your teacher can see at least 2 points on the line. Okay. So that you are anchoring your line, because the teacher's going to want to know that you put the line in the right spot. So 2 points that are clearly visible. I would put a dot there. I've had students just put the line, and the line is beautiful, and I'm sure they used a ruler and everything. But I have to look really, really closely to see where the points actually are. If you put the dots there, it just makes it easier on your teacher to see, yes, you put the line in the right spot. Make sure that it is clear if it is dashed. So if it is a solid line or a dashed line. And here's what I mean by that. I have had students sometimes that are maybe not confident, and they will do this when they go to shade. Okay, so they will. And what they do in their zeal for shading is they have actually obstructed my view of the line so that I can no longer tell whether the line was solid or shaded, or solid or dashed in the first place. So when you go to do your shading, you do not have to go like crazy with it, just enough so that your teacher knows which side of the line you intended to shade. And that would get you full credit. Now, I mentioned earlier, just be careful with really, really steep lines. So lines that tend to be very, 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 very steep. I've had students that what they see when they look at it is they see the left side of the line and the right side of the line, and they lose sight of this above belowness to it. Okay. And just like be careful, because like, is that technically the left side? And are there times when you need to know that? Yeah. But really this is the above side and this is the below side. And it's not always like left or right. So if I were to turn this line around, okay, now this side is below and this side is above. So I've had students really look for some patterns there, and they're looking at the wrong patterns. You just want to think like above, like where is the greater, where is the less, where is the greater, where is the less. If that seems painfully obvious to you from the way I taught it, then I'm going to say you probably did a good job explaining it. But these are just things that I've seen in my classroom just to be aware of. Okay. And that's it. So 23 minutes, and we have covered everything you always wanted to know. Don't forget to like and subscribe for more math help. Drop a comment question below. Check out some of the other content on the channel. There's a playlist that focuses on multiple choice questions and ways to navigate that. And there's also a playlist that focuses on Desmos help for using the online resource Desmos. Work the practice set for this lesson. I'll link that in the description, and so that will reinforce what we went over. So thanks a lot. I'll see you in the next video.